A method that the authors of Python built into the str class, but it's been there from the get-go. So this notion of methods is not even new today. You and I have been doing it for this long. If you've ever called strip to remove the leading and the trailing white space from a string in Python, you are calling another method that came with Python, written by the authors of Python. And even though we didn't call it a class at the time, a str all this time has been a class. And instances of strings are themselves objects, and those objects come therefore with these functions built in, aka methods, that allow us to do things like force to lowercase and strip white space from the beginning and end. Let's do another. List. Anytime you've created a list, either syntactically with square brackets or literally with list, open parenthesis, close parenthesis, which is also possible, you have been using a class. If you go to the documentation for list at this similar URL here, or more specifically, the tutorial on lists here in Python, you will see that a list is and has been, since the early weeks of this class, a class itself. And that list class takes, as part of its initialization, an optional iterable, something that can be iterated over, like 1, 2, 3, or some list of values. And you can then get back a list containing those same iterable values. If you've ever appended something to a list in this class, as I have myself in the past, you've been using a method called append that comes with the list class that per the X here takes an argument that allows you to append something to the current list, aka self, in the context of that method. We can do this all day long. If you've used a dictionary or a dict in Python, I've actually all this time been calling them dict objects, and that's for a reason. Dict itself is a class in Python. If you pull up its official documentation here, and you'll see that it is defined indeed as itself a class, and that class comes with methods as well. And so anytime we've manipulated dictionaries, we've been underneath the hood using all of those same methods. And in fact, we can see this if we're really curious. Let me go back over here to VS Code, and let me go ahead and create a new file that very simply does something like play around with data types. And let me go ahead and create a new file, for instance, called, say, type.py, just so that I can poke around inside of some values. And in type.py, I'm just going to go ahead and do this. I'm going to print out whatever the type is of, say, the number 50. And this is a function you've not necessarily seen me use already, and it's not one you would frequently use in your own code. There are other ways to detect, if you need to, what the type is of a variable. But in this case, type of 50 is just going to tell me and then print out what the data type is of that value. Now, hopefully, all of us could guess that 50 is indeed going to be an integer, that is an int, but we can see it in this way. And this, too, is what's powerful about knowing a bit of programming. If you want to know the answer to a question, just try it out, like I am here. So let me go ahead and run Python of type.py, enter, and there it is. When you print out the type of the number 50, you'll see on the screen in this cryptic syntax, class quote unquote int. This is not something that you'd probably want to show to the user, but if you yourself just want to poke around and see what's going on, or maybe use that information somehow, it's certainly at your disposal to use with this type function for that. Let's change it around a little bit. Instead of passing as the argument to type 50 as an int, let's type something also familiar, like hello, comma, world in double or single quotes. Let me go back to my terminal window, clear the screen, and run Python of type.py again. And now, voila, there it is. All this time, a str is also a class. We can do this a few more times. For instance, let's go ahead and change hello, world to just an empty list. Open square bracket, close square bracket. And this is starting to look a little cryptic, but again, notice what I'm doing. In square brackets is an empty list. We've done that before. That is the sole argument to this new type function, and that's just being passed to the print function so that the return value of type is the argument to print. So if I now run this code, Python of type.py, there it is. A list is a class too. You might recall that I said that you can also create an empty list by literally doing list, open parenthesis, close parenthesis. This is a bit of an inconsistency, as we can now identify that int and str and now list, they're technically all lowercase. And I went to great lengths of creating my student class to have that capital S. And that's a convention. Because int and str and list and others come with Python, they decided to make their built-in data types, even though their classes all lowercase. But the convention, the recommendation in the Python community when creating your classes is indeed to capitalize the first letter, as I did in something like student, capital S. But list, open parenthesis, close parenthesis is identical to really just two empty square brackets. If I clear my screen and run type.py again, you see the exact same thing. The class is called list. Let's do one more. Let me change list to be not square brackets, but curly braces. We've done this before. Anytime I've done two curly braces with nothing in between, this, of course, is an empty dictionary or a dict object in Python. Well, we can see that now. Let me clear my screen, run Python of type.py, enter, and there it is, class dict. It's been there this whole time. We just didn't call it a class until today. I can similarly do this one explicitly. Instead of two curly braces, let's write out dict with two parentheses. Now we have a lot of parentheses again, like with list, but this is just making even more clear that the type of a dict object is indeed the class dict itself. So this is to say that as new as a lot of today's idea and syntax might be, you've actually been using it, perhaps unbeknownst to you, for weeks now. We now just have terminology to describe what it is we've been doing all this time, and you now have the expressiveness with some practice to create your own classes, inside of which are your own instance variables, perhaps wrapped with those properties and your own instance methods. But it turns out there's other types of methods in the world. Thus far, I've been deliberate in calling all of our variables instance variables and all of our methods instance methods. It turns out there's other types of variables and methods out there, and one of those is called class methods. It turns out that sometimes it's not really necessary or sensible to associate a function with objects of a class, but rather with the class itself. An instance, or an object of a class, is a very specific incarnation thereof. Again, on that neighborhood that has a lot of identical looking buildings, but they're all a little bit different because of different paint and such. Sometimes you might have functionality related to each of those houses that isn't distinct or unique for any of the houses. It's functionality that's going to be exactly the same no matter the house in question. Same in the world of object-oriented programming. Sometimes you want some functionality, some action to be associated with the class itself no matter what the specific object's own values or instance variables are. And for that we have a keyword called @classMethod. This is another decorator, really another function that you can use to specify that this method is not by default implicitly an instance method that has access to self, the object itself. This is a class method that's not going to have access to self, but it does know what class it's inside. So what do I mean by this? Well, let me go back to VS Code here, and let me propose that we create a new file this time, implementing the notion of the sorting hat from the world of Harry Potter as well to stay on theme. I'm going to go ahead and run code of hat.py. And in hat.py, let's implement the notion of this sorting hat. If unfamiliar, in the books and in the films, there is literally a pointy hat that when a student puts it on their head, that sorting hat, so to speak, decides what house the student is in, whether it's Gryffindor or something else. So let's implement in code this notion of a sorting hat such that when we pass to the sorting hat the name of a student, like quote unquote Harry, this sorting hat implemented in code will tell us what house that student should be in. All right, well, let's go ahead and do this. In hat.py, first let's go ahead and define a class called hat. And then let's get back to implementing it itself. And I find this to be a helpful technique, not just with teaching, but when writing code. Like, I know I want a hat class. I don't necessarily know what I want it to do yet, so I'm going to create this sort of placeholder ... So I'll come back to that. Let's now try to use this class as though it existed. And from there, I perhaps can realize exactly what functionality that class needs to have to support my use case. Let me go ahead and create a variable called hat in all lowercase and instantiate a hat object. So no matter what the hat class ends up looking like, this is the common syntax for instantiating an object of a certain class. In the past, we saw student, all lowercase, equals capital student, open parenthesis, close parenthesis, and then eventually we added in things like name and house. For now, let's assume that the hat is much simpler than a student, and it only has sorting capabilities, so I'm not going to even pass any arguments there too. Indeed, let me assume that the sorting hat has one function, one method inside of it called sort. And so if I do hat.sort, quote unquote Harry, let's propose that that prints out what house that student should be in. So that's it. I'm going to encapsulate, that is, tuck away inside of a hat class all of this requisite functionality, and I'm going to print out onto the screen what house Harry belongs in. All right, now I think I need to get into the weeds of actually initializing this class. Well, let me go ahead and do this. If I don't care to parameterize hat, I just want to, for instance, sort values. Let's go ahead and define this function sort first. So let's define sort as taking a first argument self, which is always going to be the case when defining an instance method as before. But the sort method clearly takes one argument from the programmer, me, namely the student's name. And again, we've seen this dichotomy before. Even though I'm trying to pass in one argument, when I define the method, it's got to take that many arguments plus one more, self, which is always going to be automatically passed in by Python first. All right, what do I want to do? Well, let's go ahead and do something like this. Print, quote unquote, or rather print this name. How about quote unquote is in, quote unquote, some house. I'm going to again use some placeholder code for myself because I'm not quite sure how to finish implementing this sorting hat. But I think that's enough to just test where my code is at now. Let me go ahead and run Python of hat.py and hit enter. And it looks like, indeed, Harry is in some house. We're not done yet because it's clearly not doing anything interesting. but it at least is running correctly with no errors. Well, let's go ahead now and decide what house Harry should actually be in by introducing a bit of randomness and choosing a house randomly. Well, I can do this in a few ways. Let me go ahead and do this. I need to have a list of houses somewhere. So where can I put that? I could solve this problem in different ways. Let me propose that I do this. Let me define a method called init, as I've done before, that takes in self but no other arguments. And whenever the sorting hat is instantiated, let's do this. Let's create a houses instance variable, plural, that equals this list. Gryffindor, comma, Hufflepuff, comma, Ravenclaw, comma, Slytherin. So the exact same list that we've used before, and I'm storing it in an instance variable inside of this class. I'm not taking any arguments beyond self to init, but I just need this list of values somewhere, for instance. So what can I do here? Well, let me go ahead and replace some house with the actual house. Well, what could I do here? Well, I want to put a house there. Well, let's go ahead and create a variable called house. And if you think back to our discussion of libraries, in the random module, there is a function called choice that if you pass in a list of choices, like self.houses, that will pick a random house out of those 4. And then on line 7, I can pass it in. If I want to tighten this up, let me just go ahead and highlight that code, get rid of the variable. It's technically unnecessary. And because the line of code is still pretty short, I'm OK with just putting it all in one line. But I could certainly use the variable like I did a moment ago. So what have I done? In my init function, I have defined a initialization of the object that stores in self.houses the list of 4 houses. And then in sort, I'm accessing that same list, but I'm randomly choosing the set of houses there. Now, why have I done it in this way? This too is general convention. Anytime you have a list of things that, who knows, maybe will change over time. Places like Harvard have constructed new houses over the years, so you might have to change the list of available houses. It didn't happen in 7 books or 8 films of Harry Potter, but you could imagine maybe Hogwarts eventually has a 5th house. So there's generally some value in putting list of constants toward the top of your file, toward the top of the class. So it's just obvious what the list of values is. You don't want to necessarily tuck it away in some function like sort, especially if you might want to use that function especially if you want to use that list in multiple functions. Not just sort, but if I kept adding to this class, you might want to use that same list of houses in multiple functions. So let's keep it in the object itself by storing it in self.houses. All right, well, we're about to change the course of history here, perhaps. Let me do Python of hat.py, and I think we're about to assign Harry to one of those 4 houses randomly. Name error. Name random is not defined. Well, wait a minute. Where did I go wrong here? Thinking back to our class on libraries, why did my code break and not tell me where Harry is to be?
You do not import the random library.
Exactly. If the random library or module is something I want to use, I need to tell Python that at the top of my file. So let me go up here and do import random. And then below that, let me go ahead and clear my terminal window and try again. Python of hat.py, crossing my fingers, seeing where Harry is going to end up. And OK, Harry, as of now, is officially in Hufflepuff, despite everything you've read or seen. Well, let's run this again. Let me clear my window and run Python of hat.py. And now he's in Ravenclaw. That's consistent with using random. Let's clear that and run it again. He's still in Ravenclaw, but that could happen even though there's 4 choices. Let's do it again. Hufflepuff, back in Hufflepuff. We can't seem to get the right answer, so to speak. Now he's in Gryffindor, albeit randomly. So we seem to have a program that, based on these limited tests, seems to indeed be assigning Harry to a house randomly. Now, I'm somewhat lazily just letting sort print out this value. I could do something else like return a string and then let me, on line 13, do the printing for me. But for now, I think we have an example of a class called hat that nonetheless applies some of our lessons learned thus far today, where I've created a class because a sorting hat is, frankly, well, I was about to say real world entity, but really a fantasy world entity. And indeed, that's a perhaps common heuristic or mental model to have. When should you use a class to represent something in your code? Very often when you're trying to represent some real world entity or fantasy world entity, like a student which is something in the real world, like a sorting hat, which, okay, doesn't exist, but hats certainly do, so quite reasonable to have a class for hat. And that's not always the case, that classes represent real world entities, but indeed we've seen thus far that int and stir and list and dict, these are all structures that you might have in the real world. We have integers and strings of text and other things, so it rather makes sense to represent even those things more technically using a class as well. You could use just a dictionary to represent a student or a hat, but again, with classes come all this and even more functionality. But I honestly am not using classes in really the right way here. Why? Well, in the world of Harry Potter, there really is only, to my knowledge, one sorting hat. And yet here I have gone and implemented a class called hat. And again, a class is like a blueprint, a template, a mold that allows you to create one or more objects thereof. Now, most of my programs thus far have been pretty simple, and I've just created one student. But certainly if I spent more time and wrote more code, you could imagine writing one program that has a list of students, many more students than just the one we keep demonstrating. Yet it would be a little weird, it's a little inconsistent with the real or the fantasy world of Harry Potter to instantiate 1, 2, 3, or more sorting hats. There really is just one. Really one singleton, if you will, which is a term of art in a lot of contexts of programming. So let me propose that we actually improve the design of the sorting hat so that we don't have to instantiate a sorting hat, because right now this is kind of allowing me to do something like hat 1 equals hat 2 equals hat 3 equals, and so forth. I don't really need that capability. I really just need to represent the sorting hat with a class, but I don't really need to instantiate it. Why? Because it already exists. I need just one. So it turns out in Python that up until now we've been using, as I keep calling them, instance methods, writing functions inside of classes that are automatically passed a reference to self, the current object. But sometimes you just don't need that. Sometimes it suffices to just know what the class is and assume that there might not even be any objects of that class. So in this sense, you can use a class really as a container for data and or functionality that is just somehow conceptually related. Things related to a sorting hat. And there's this other decorator or function called class method that allows us to do just this. So let me go back to my code here and let me propose that if I'm not going to instantiate multiple houses, I don't really need this init method, because that's really meant to initialize specific objects from that blueprint, that template, that mold. So let me get rid of this. But if I get rid of this, I no longer have access to self. But that's OK, because it turns out, in addition to their existing class methods, there are also what we might call class variables. And class variables exist within the class itself, and there's just one copy of that variable for all of the objects thereof. They all share, if you will, the same variable, be it an int or stir, or in this case, a list. So what I've done here is define inside of my hat class in a class variable called houses. I don't say self, because self is no longer relevant. Self refers to specific objects. I want a variable inside of this class, aka a class variable that equals that list. Because it's inside of this hat now class, I can use that list in any of my functions. I've only got one now called sort, but if I had more, it would be accessible to all of those methods as well. And with sort, it also doesn't really make sense to sort within a specific sorting hat, because again, I only want there to be one. So I can actually specify that this is a class method. By saying @class method, and I don't pass in self anymore. I actually, by convention, pass in a reference to the class itself. It's typically written as CLS. Why? Well, if you wrote CLASS, that would actually conflict with the keyword class that we keep using up here. So the world realized that, oops, we can't reuse that same phrase here, so let's just call this class. This is useful in some contexts, including this one. Why? Well, notice what I can now do. I can now change self to be just class. Why? Because houses is now not an instance variable accessible via self.houses. It is now a class variable accessible via class.houses, or technically CLS.houses in this case. But now the final flourish is this. Now I don't have to instantiate any hat objects as I used to on here, line 13. I can just use functionality that comes with this class. So I'm going to delete that line altogether. I'm going to capitalize the hat on this new line 13 and just say hat.sort, quote unquote, Harry. So what have I done? I've not bothered instantiating an object of type hat. I am just accessing a class method inside of the hat class that, you know what, is just going to work. This is how class methods work. You use the name of the class, capital letter and all, dot method name, passing in any arguments you want. Python is going to automatically pass in some variable via which you can refer to that class in that function that you've implemented inside of that class, so that I can do something like this. It's not that I want a variable called houses locally in this function. I want the variable called houses that's associated with this current class. So I can still access this same list that I defined on line 6. And now, if I go back down here to my terminal and run python of hat.py, enter, Harry is still in Hufflepuff. Once more, Harry is still in Hufflepuff. Once more, Harry is back in Gryffindor, at least randomly. Questions now on these class variables or these class methods, which are in contrast with instance variables and instance methods. And the one thing, at least, that's a little strange here is that even though there's a decorator called @classMethod, there is not one called @instance_method. A method is just automatically a so-called instant method when you define it without any decorator.
Can you have a class inside another class?
You can. You can define one class inside of another. Generally speaking, this isn't done, but there are cases where it can be helpful, especially for larger, more sophisticated programs. So yes, it is possible. Good. Other questions?
The question was about the self.houses. When we remove it, and we pass data, the variable is created itself. Why we remove the self?
So in the previous examples, both of the hat demonstration and also all of the student demonstrations, we were creating a student object by calling student, capital S, open parenthesis, close parenthesis, with eventually name and a house passed in. And then we were using the double underscore init method to initialize the self.name and the self.house instance variables therein to those respective values. In this latest version of the sorting hat, I haven't bothered with self anywhere, only because conceptually, I don't need or want there to be multiple hats in the world. I'm just using the class as kind of a container to bundle up this list of houses, this sorting functionality. Maybe eventually I'll add more functionality to it, but that's it. And so sometimes you can use object-oriented programming in this somewhat different way when you want there to be functionality, but it's not specific to any one specific hat. It's specific to the sorting hat itself. How about one other question now on these class variables or methods? Just another way of using object-oriented programming, but to solve a somewhat different problem.
Well, what's the difference between the class hat and, I don't know, like a function of hat?
A good question. So why are we using a class at all and not just having a file called hat.py with a variable called houses and a function called sort? Like, why are we adding this complexity? In this particular case, we don't necessarily need to. I could absolutely go in here. I could get rid of the class. I could undo this indentation. I could get rid of this decorator. And I could get rid of hat dot. And I could just do this. And additionally, let's get rid of class here. Let's get rid of class here. And now run python of hat.py, enter. And it still works. Put Harry in the wrong house, but that's what happens randomly. That's fine too. What we're introducing today by way of object-oriented programming is just a different way of modeling the world. It's not really compelling with an example like this, frankly, that's relatively simple. It's not very complex. There's not much functionality. Honestly, the version that we just typed up, these 10 lines, this is fine. This solves this problem. But as our code gets longer, as we start collaborating with other people, as the problems we're trying to solve with code get more sophisticated, you're going to find that your code gets messy quickly. And you're going to find that you have a huge number of functions, for instance, in one file, and some of them are related to each other, but some of them are not. Well, at that point, wouldn't it be nice to just organize them a little differently? And in the world of Harry Potter, let's have a class for student. Let's have a class for professor. Let's have a class for the sorting hat. Let's have a class for something else. And so once your world gets much more complicated than some of the demonstrations we do here in class, when we want to focus on individual ideas, object-oriented programming is just a way of encapsulating related data, that is variables, related functionality, that is methods, inside of things that have names. These things are called classes. So it's just another way to solve problems. And when we focused on libraries a couple of weeks back, that too was another solution to the same problem. You could define your own modules or packages, put some of your data and or functionality in there, and that's fine too. And sometimes which one you should use overlaps. If you're familiar with Venn diagrams, the overlapping region might mean that you could use a class, you could use a module or a package, you could just use a single local file. Over time, you'll develop an instinct and maybe even a personal preference for which tool to use. All right, let me propose now that we apply this same idea of a class method to clean up one other thing as well. Let me close hat.py and reopen student.py as we left it earlier. And let me go ahead and simplify it just a little bit. I'm going to go ahead and get rid of the properties, not because there's anything wrong with them, but just because I want us to focus on some of the key ideas when we began with this program. So I'm going to go ahead and keep main as well. I'm not going to adversarially try to change Harry's address there. I'm going to instead go ahead, though, and just print the student. But this is the thing I want to focus on here. This, in our previous student examples, was kind of a missed opportunity to clean up my code. Well, what do I mean by that? Well, up here at the top of this file, even though I've simplified it by getting rid of the properties and all of that error checking, because I want to focus on the essence of this class now, just the student's name and the house and the printing thereof, this is, by nature of classes and object-oriented programming, theoretically all of my student-specific functionality. That is to say, if I have functionality and data related to a student, you, the programmer, my colleague, would assume that it's all bundled up, encapsulated, so to speak, inside of the student class. And yet, if you scroll down further, what is this? Like, there's a function called getStudent that just exists elsewhere in this file that prompts the user for a name, prompts the user for a house, creates the student object, and then returns it. Like, that's not wrong. Like, it works, and we saw many, many times it kept working. But this is a little weird, right? Because if this is a function that helps you get a student, helps you get the name of a student and the house of a student, why isn't that functionality in the class itself? After all, as my code gets more and more complicated and does more things, I'm going to be looking at the student class for all student-related functionality. I'm not going to be scrolling down expecting that, oh, maybe there's some other student functionality just kind of randomly later in this file. So it's not wrong, but this is, again, evidence of maybe bad design. Not so much with this small program, but this is an example, again, of code smell. Like, something smells a little off here. Like, this is probably going to get us in trouble by separating related functionality. So again, it's a design principle, not a correctness concern. But class methods allow us to address this too. Let me go ahead and do this. I'm going to delete getStudent altogether, leaving only main as my other function here. And inside of my student class, I'm going to do this. I'm going to define a function, even more simply called get. And by nature of how class methods work, it's going to take in the name of the class itself, or a reference there too, as an argument. And I'm going to move the functionality from getStudent into the student class. And I'm going to do this. Name equals input, quote unquote name. House equals input, quote unquote house. And then what this function is going to do is return a new student object by calling class, which again is just an automatically passed in reference to the class itself, passing in name and house. And I will admit, this syntax seems a little strange that now I'm calling CLS and I'm passing in these arguments, but let me do one final fix here. Let me go to the top of this function and more explicitly say this is a class method. This solves a potential chicken and the egg problem, so to speak, whereby one needs to come before the other potentially. So what am I doing here? Inside of my student class, I now have a function called get. It is, I shall claim, a class method. What does that mean? It just means I can call this method without instantiating a student object first. Therein lies the potential chicken and the egg problem. And if unfamiliar, that's an expression meaning, well, did the world have chickens first that laid eggs? A student means I can call this method without instantiating a student object first. Therein lies the potential chicken and the egg problem. And if unfamiliar, that's an expression meaning, well, did the world have chickens first that laid eggs, or was there an egg that then yielded the chickens, but how did the egg get there? It's this sort of weird circular problem, and that's what we're facing here. It would be weird if you had to create a student object in order to call get, in order to get another student object. Like, that sounds messy. Let's just get a student via a class method that by definition does not require you to create a student object first. Just like the hat. In its final form, we use the hat class to just say hat, capital H, dot sort. We didn't need to create a hat first. We just used the class itself. So what am I going to do here now? Let me go down to main, and instead of saying get student, notice what I can now do. Student.get. And everything else can stay the same. All I've done now is I've migrated all of my logic from get student, which was its own standalone function, but clearly related to students by name. I've moved the same code, really, to inside of the student class in a more simply named function called get, but I could still call it get student if I want. It just seems a little redundant to call it get student in a student class, so I'm simplifying. So I have a method called get, but I'm calling it a class method to avoid that chicken and the egg problem. I want to be able to call get without having a student object in my universe already. And the syntax for that is at class method. The convention is to give this method at least one argument, by convention called CLS for class, which is just going to be a reference to the class itself. Lines 11 and 12 are identical to what they've always been in get student. The only new syntax here is this, but this again is one of the features of object-oriented programming. You can now instantiate a student object by just using CLS that's passed in. I technically could use student capital S, but it turns out I'm doing what's more conventional because this will both solve and avoid problems down the line with more complicated code. This line here on line 13 just means create an object of the current class. What class is that? Well, whatever CLS is. Well, that, by definition of how it all works, is going to be student. And I want you to initialize it, as always, with name and house. So now, scrolling down, my code is this. And this is just nice to read. You did perhaps have to acquire a taste for this, and I sound a little odd saying this is nice to read, but indeed, student.get just tells me what's going on. I'm going to get a student. I don't need a separate function written by me called getStudent in the file itself. The get functionality is built into the class. All my student-related code now is together. So let me go down to my terminal window and run Python of student.py, enter. Let's type in Harry. Let's type in Gryffindor. And we're back to where we began. But, everything related to students now is in this here class. The only other thing in the file is main and this conditional that we always use to avoid accidentally executing main when we're making a module or a package or the like. So again, a solution to a problem, not a big one in the case of a relatively small program, but one that you will eventually encounter as your programs get longer and longer with more and more entities to represent. Questions now on this use of a class method.
Does the class have to be defined before the main function in terms of the order of the program?
A really good question. So when in doubt, let's try this. So let's try to change the order. Let's move main to the top, which I've often encouraged. So let's go ahead and above the class do this. And notice now that technically line 2 is mentioning student, which does not exist until line 6 and below. Let me go ahead and clear my terminal and run Python of student.py. So far, so good. Harry, Gryffindor. Okay, and indeed, Harry's from Gryffindor. The reason, Michael, it does not matter in this case is because we're not actually calling main until the very end. And just as in the past, that means that Python has a chance to read everything, top to bottom, left to right, so everything exists. I would say generally, classes are defined at the top of the file. However, it would be even maybe cleaner to move the class's definition to its own file and then import it. So essentially to make reusable code by putting it into your own module or package so that not just this program, but many others can use that definition of student as well. Other questions now on classes, class methods, or the like.
I wanted to ask: is there a way to like declare all the possible attributes of the class, because it looks so inconsistent?
Well, so my takeaway there is this is Python's approach to these principles. Different languages like Java just take a different approach but have very similar features. The syntax just tends to vary. And this is how the Python community chose to implement this idea. The right mental model ultimately is that these instance variables, instant methods, belong to or operate on specific objects, a specific student, a specific hat. Class variables and class methods operate on the entire class itself, or in turn, all objects of that class, which we've not seen a demonstration of, but it's sort of a higher level concept. So it turns out besides these class methods, which are distinct from those instance methods, which to be fair, do not have their own decorator, they just are by default instance method, there's yet other types of methods you can have in classes in Python. They tend to be called static methods, and they too come with another decorator called @static method, which is a rabbit hole we won't go down, but realize that there is yet other functionality that you can leverage within object-oriented programming. But what we thought we'd do is focus really on some final core features that you see not just in Python, but other languages as well. And perhaps one of the most compelling features of object-oriented programming that we haven't yet used explicitly, though it turns out we've seen implicitly over the past weeks, is this notion of inheritance. It turns out via object-oriented programming, there's actually an opportunity to design your classes in a hierarchical fashion, whereby you can have one class inherit from or borrow attributes, that is, methods or variables from another class, if they all have those in common. So what do I mean by this here? Well, let me propose that we implement over in VS Code here a brand new file called wizard.py. Let me go ahead and run code of wizard.py. And then let's start as before defining a class called student. And let's go ahead and first define the underscore init method, which of course is minimally going to take an argument traditionally called self. And in this case, let's also have it take as before a name and a house. And then in this init method, let's go ahead and assign the instance variables self.name equals name and self.house equals house. Let's assume that there's some other functionality in this class as well, ... But let's move on now to implementing the notion of a professor in the wizarding world as well. So for this class, let's call it professor. And a professor, let's say, is also going to have its own initialization method. So underscore init. It's going to take self, as always, as the first argument. A professor also has a name, so we'll pass that in second too. And even though some professors are heads of houses, let's assume that a professor is really identified by their name and their subject area, the class that they teach. So we'll call this third argument subject. Now, as before, let's go ahead and assign self.name equals name, and let's assign self.subject equals subject here. And as before, let's assume that there's some more functionality associated with professors as well. Well, what do you notice already here in my definitions of students and professors? Typically, we're a bit reluctant to allow for any redundancy in our code. And here, I feel like my init method is taking a name for student. My init method is also taking a name for a professor. And I have these identical lines of code like self.name equals name. And this is only going to get exacerbated if I now go and add some error checking. So for instance, how about if not name, we should probably be in the habit of raising something like a value error in an explanatory message like missing name. And you know what? If a professor's missing their name, I should probably copy paste that code down here. And that's where the red flag should be going off, whereby as soon as you start copy pasting code, there's probably a better way so that we can write the code once and perhaps reuse it in some way. And here too, object-oriented programming offers a solution. It turns out that object-oriented programming in Python also supports inheritance, whereby you can define multiple classes that somehow relate to one another. They don't need to exist sort of in parallel in this way. There could actually be some hierarchy between them. So for instance, in the wizarding world, we could argue that both a student and a professor are, at the end of the day, wizards. So maybe what we should really define is a third class, for instance, called wizard, that has any of the common attributes for students and professors alike. And for now, we've kept it relatively simple. The only thing they have in common is a name and a name in student and professor respectively. So why don't we minimally factor that out first? All right, so let me go ahead here. And just to keep things organized, at the top of my file, let's define a third class called wizard. And a wizard will have its own initialization method. So def underscore underscore init underscore underscore and self as always. And a wizard, let's say for now, is only going to be initialized with their name in this way. And now I'm going to go ahead and do some of that error checking. So if not name, we'll raise a value error in the wizard class. Otherwise, we'll go ahead and do self.name equals name, and heck, dot, 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 maybe some other functionality as well. But not a subject, which is specific to professors, and not a house, which I've claimed is specific to students. Now, I think we can begin to maybe remove some of the redundancies in our other classes here. So for instance, down with student, why don't I go ahead and remove this error checking here and remove this error, this assignment of self.name equals name, because I'm already doing that in wizard. And similarly down here in professor, why don't I do the same? Let's get rid of the error checking. Let's get rid of self.name equals name, because again, I'm doing that already up there for wizard as well. But at the moment, even though they're all in the same file, I haven't told Python that a student is a wizard and a professor is a wizard, so I really need to link these two together. And the way you can prescribe inheritance, whereby one class should inherit from another, or conversely, one class should descend from another, we can do this. I can say class student, but before the colon, I can go in and say in parentheses, a student inherits from or is a subclass of wizard, which conversely is the superclass of the student class. So this just means that when I define a student class, go ahead and inherit all of the characteristics of a wizard as well. And I'm going to do the same thing for professor. So parenthesis, wizard after the class name professor, and that's going to give me access to some of that same functionality. But because my student class and my professor class still have their same init methods, those are the methods that are going to get called whenever I create a student in code or I create a professor in code. I need to somehow explicitly say that I also want to use the functionality in the wizard class's init method. And the way to do this in Python is as follows. Let me go into my init method for student, and let me call super with no arguments, which is a reference to the super class of this class. So if this class is student, the super class, that is the parent class, is wizard. So super, open paren, close paren, will have the effect of accessing the super class, and then I'm going to go ahead and explicitly call its init method, and I'm going to pass to the wizard's init method the name that the student's init method was passed. And I'm going to go ahead and do the same down here in wizard. This is one line of copy paste, but I think I'm okay with it here because it's still allowing me to do all of the name assignment and the error checking up in the wizard class instead. I think we're okay now by just calling super.init for both student and professor alike. Now, admittedly, this syntax is definitely out there. The fact that we're calling super in parentheses and dots and underscore underscore on the left and the right of init here, but it's just a combination of these two ideas. Super, open parenthesis, close parenthesis, is a way of programmatically accessing a current class's parent class or superclass, and underscore underscore init, of course, is just referring to now that class's own initialization method. Now, per the dot, dot, dots, there could be a lot more going on in these classes, but what's nice now is that wizard as a class is taking care of all of the assignment of a wizard's name, whether that wizard is a student or a professor, and it's even doing some error checking to make sure that the name was actually passed in. Meanwhile, student is inheriting all of that functionality and using it by calling the superclass's own init method, but it's additionally taking the house that's presumably passed into the student constructor function and assigning it to its own instance variable, self.house. And similarly, professor are restoring in self.subject the subject that was passed into that one as well. Now, how might we use these classes? Well, we'll continue to wave our hands with a little bit of detail here, but if at the bottom of this file or any other file that imports this one, I could now write code like this. I could create a student variable and assign it the return value of the student constructor call, and maybe that student is named Harry, and that student's house, for instance, might be Gryffindor. And meanwhile, I might do something like this. Professor equals professor over here. And notice the lowercase s on the left capital S on the right, same for professor on the left, lowercase and uppercase on the right, respectively. Professor, quote unquote, Severus, and how about defense against the dark arts will be his subject. And meanwhile, if we want more generically just a wizard who at the moment is neither student nor professor teaching classes actively, we could even do that. We could do wizard equals wizard in capital W on the right hand side of the equal sign because it's the name of the class, and someone like Albus, passing in only Albus's name, not a house, not a subject, because in this case, he's known only as a wizard. Meanwhile, with each of these calls, this line of code here will ensure that the init method for the wizard class is called. This line of code here will ensure that the init method of the student class and in turn the init method of the superclass wizard is called. And then lastly, on this final line of code, will this syntax ensure that the init method of the professor class is called, which in turn calls the init method of the superclass as well. Any questions now on this idea of inheritance, which is a key feature of a lot of object-oriented programming languages?
So is there any situation where, because from what I've seen so far, a lot of times there's like a lot of nesting. If you do super, does it go one up? Is there any situation where, you know, it's nested in another class as well, above wizard, let's say?
A really good question. If you were to have a super class, so your hierarchy is even taller than the 2 levels of hierarchy that we currently have, absolutely. But what's nice about what's nice about inheritance, as the name implies, is just as you might have inherited certain traits as a human from your grandfather and grandmother, or your great-grandfather or great-grandmother, some of those properties can actually trickle down to you, so to speak, in the context of code as well. So when you descend from another class, that is, when you subclass a superclass or a superclass, you actually do inherit all of the functionality, not just from one level above you, but from 2 or 3. So you can indeed access some of that functionality as well, and you can even override it if you want some of these classes to behave a little bit differently than others. Other questions on inheritance?
So it's kind of similar to the last one, but can you have like 2 parents on the same level?
A really good question. So there are ways to implement descendants from multiple parents, and there's different ways to do this, not just in Python, but other languages. We've kept things simple here, though, by having a single inheritance path. A good question. How about one more question on inheritance?
Can we have multiple arguments in super dot double underscore init?
Yes, but in this case, I'm only passing in name on line 18, and I'm only passing in name on line 10. Why? Because on line 2, when I define the init method for the wizard class, I only expect a single argument. But I could absolutely have other common functionality, like I could add in a patronus. If both students and professors have patronuses that can come out of their wands, I could have 2 arguments instead. We've been using this feature of object-oriented programming now for quite some time in the form of exceptions. Indeed, if you look at the official documentation for exceptions in Python, you'll see that there's not even the ones we've seen in class, like value error and others. There's any number of others as well, but they are all themselves hierarchical in nature. This is just a subset of the available exceptions that come built into Python, and you can actually, as a programmer, create your own exceptions as well. But as this chart here captures hierarchically, all exceptions we've seen thus far actually descend from or inherit from superclasses already. So for instance, at the bottom of this list here is value error, which we've seen quite a bit. And if you follow the line straight up on this ASCII rendition of this chart, you'll see that value error has a parent class or superclass called exception. And the exception class, meanwhile, has a parent class called base exception. Why did the authors of Python do this? Well, it turns out that whether you have a value error, your own, but they are all themselves hierarchical in nature. This is just a subset of the available exceptions that come built into Python, and you can actually, as a programmer, create your own exceptions as well. But as this chart here captures hierarchically, all exceptions we've seen thus far actually descend from or inherit from superclasses already. So for instance, at the bottom of this list here is value error, which we've seen quite a bit. And if you follow the line straight up on this ASCII rendition of this chart, you'll see that value error has a parent class or superclass called exception. And the exception class, meanwhile, has a parent class called base exception. Why did the authors of Python do this? Well, it turns out that whether you have a value error or a key error or an assertion error or any number of others, there's a lot of functionality common to all of those types of errors that you want a programmer to be able to use. And so it turns out that the authors of Python decided, you know what, let's not have a dozen or more different classes that all just have copy-pasted similar functionality. Let's create this hierarchy so that even though the exceptions toward the bottom of this list are very precise, they at least inherit, that is, borrow some very common functionality up above. So it turns out that when you use the try and the except keyword in Python, generally speaking, we've tried to catch very specific exceptions like value error. But technically, you could capture the parent or even the grandparent exception for a given exception, especially if you're not necessarily sure which one is going to get raised, or better yet, there could be many exceptions that get raised, but you want to handle them all the same, and you don't want to necessarily enumerate them in parentheses separated by commas. You want to say you want to handle all exceptions of a certain superclass in much the same way. So this has been latent this whole time. Anytime we've seen or used or caught or now raised exceptions, and built into Python is this hierarchy. And if you were to invent your own exception, generally you wouldn't want to start from scratch. You would want to descend from, that is, subclass one of these existing exceptions and add your own twist on it, your own functionality as well. Well, there's one final feature of object-oriented programming that we'd like to share with you today, and that it will perhaps be quite the eye-opener as what you can really do now that you have classes at your disposal. And this too, surprise, has been a feature you and I have been taking for granted for weeks now. This has just worked, but it's been implemented in a way that you can now leverage yourself. It turns out that Python and some other languages too support this notion of operator overloading, whereby you can take very common symbols like plus or minus or other such syntax on the keyboard, and you can implement your own interpretation thereof. Plus does not have to equal addition, and minus does not have to equal subtraction. And in fact, you and I have already seen another context in which plus means something else. Plus has not always in Python meant addition per se. What else has Python used plus for?
Concatenation.
For concatenation, for joining two strings, for adding to a list. Can you use plus as well? So plus has actually been, funny enough, overloaded by the authors of Python for us, and so we can use the same symbol in much the same way as addition, but with different data types to solve slightly different problems. Well, let me propose that we go back over to VS Code here, and let me go ahead and create a new final file called vault.py. So code of vault.py, and let me propose that we implement the idea of a vault at Gringotts, keeping on theme, wherein there's a bank in the world of Harry Potter, and within this bank, families and individuals have vaults containing all sorts of money in the wizarding world. And the type of money that exists in the world of Harry Potter are coins called galleons and sickles and knuts. And those are in descending order of value. And so inside of a vault might be a whole bunch of coins, gold, silver, and bronze, essentially, each in those denominations tucked away. So how can I go about implementing, first of all, the idea of a vault so that I can store, for instance, for Harry Potter, how much coinage is in his family's vault, or for Ron Weasley, the same. Well, let me go ahead in vault.py and first create a class called vault, essentially meant to represent a bank vault. Perfect, another real world or fantasy world entity that I want to represent with code. I could use a tuple or a list or a dictionary, but again, I'm going to get a lot more functionality with classes, and we'll see one final flourish with operators. Inside of this vault class, let's go ahead and do this. Let me define my init method, taking its first argument of self, and let me define 3 arguments to this. When you create a vault in my code here, I want to be able to initialize it with some number of galleons, some number of sickles, and some number of knuts. I want the programmer to be able to pass in one or more of those values ideally, but they can be optional, so I'll give them defaults. So let's go ahead and define a parameter called galleons, whose default value will be 0, sickles, whose default value will also be fine. Go back over to VS Code. concatenation, for joining two strings, for adding out that Python and some other languages too support this notion of operator overloading, whereby you can take very common symbols like plus or minus or other such syntax on the keyboard, and you can implement your own interpretation thereof. Plus does not have to equal addition, and minus does not have to equal subtraction. And in fact, you and I have already seen another context in which plus means something else. Plus has not always in Python meant addition per se. What else has Python used plus for?
Concatenation.
For concatenation, for joining two strings, for adding to a list. Can you use plus as well? So plus has actually been, funny enough, overloaded by the authors of Python for us, and so we can use the same symbol in much the same way as addition, but with different data types to solve slightly different problems. Well, let me propose that we go back over to VS Code here, and let me go ahead and create a new final file called vault.py. So code of vault.py, and let me propose that we implement the idea of a vault at Gringotts, keeping on theme, wherein there's a bank in the world of Harry Potter, and within this bank, families and individuals have vaults containing all sorts of money in the wizarding world. And the type of money that exists in the world of Harry Potter are coins called galleons and sickles and knuts. And those are in descending order of value. And so inside of a vault might be a whole bunch of coins, gold, silver, and bronze, essentially, each in those denominations tucked away. So how can I go about implementing, first of all, the idea of a vault so that I can store, for instance, for Harry Potter, how much coinage is in his family's vault, or for Ron Weasley, the same. Well, let me go ahead in vault.py and first create a class called vault, essentially meant to represent a bank vault. Perfect. Another real world or fantasy world entity that I want to represent with code. I could use a tuple or a list or a dictionary, but again, I'm going to get a lot more functionality with classes, and we'll see one final flourish with operators. Inside of this vault class, let's go ahead and do this. Let me define my init method, taking its first argument of self, and let me define 3 arguments to this. When you create a vault in my code here, I want to be able to initialize it with some number of galleons, some number of sickles, and some number of knuts. I want the programmer to be able to pass in one or more of those values ideally, but they can be optional, so I'll give them defaults. So let's go ahead and define a parameter called galleons, whose default value will be 0, sickles, whose default value will also be 0, and knuts, whose default value will be 0 as well. So the programmer can pass in 1 or 2 or 3 or heck even none of those, and they'll all have some implied defaults. How do I want to remember those values that are passed in? Well, let me do this. Self.galleons equals galleons, and self.sickles equals sickles, and self.knuts equals knuts. And so I could add some error checking, especially if you don't pass in a number. I could turn these into properties to do even more validation, but let's keep it simple and, as always, focus only on the new ideas. So I'm just going to trust that these values were passed in, and I'm going to immediately assign them to these instance variables. What now do I want to do? Well, let's come up with a way of printing out what is in someone's vault, ultimately. But first, let's do this. Let's create a vault for the Potters by creating, via assignment, a new vault. And let's say that the Potters have 100 galleons, 50 sickles, and 24 knuts. All right, and that's in that vault. And let's print out, for instance, Potter. All right, let's run this code and see how it works now. Let me go ahead and run Python of vault.py, enter. Okay, seems to work, no syntax errors or anything else, but this is not very enlightening. How do I fix this? Thinking back to what we've done before. How do I fix this? Thinking back to what we've done before.
You have to use the __ stir.
Exactly. I need to use one of those special methods that comes with classes and define for myself how I want a vault to be printed as a string. So let me go ahead and do that. Let me define the stir method, taking in self as its sole argument here. And let's just return a very simple string that just reveals what's in the vault. So I'm going to return a formatted f string. inside of which is self.galleons, and then the word galleons, so I know which those are. Then let's do self.sickles, and let's output the word sickles. And then lastly, let's output self.knuts, and then knuts here. So I know in this string just how many of each of those coins I have in this particular family's vault. All right, let me go ahead and run Python of vault.py, changing nothing else except the stir method. And now we see indeed that Harry has 100 galleons, 50 sickles, and 25 knuts. All right, well, let's do one thing more here. Below that, let's go ahead and define a Weasley variable. And Ron never seemed to have quite as much money in the vault as did Harry. So let's say that the Weasley vault will have 25, 50, and 100. So I'll just reverse the order of those denominations rather than Harry's 100, 50, 25. And now let me go ahead and print Weasley like this. And let's go ahead and clear my terminal window, run Python of vault.py. This time that stir method will be invoked twice, once for each of those vault objects. And we'll see indeed that the first one for Harry's got 100, 50, and 25 respectively, versus Ron's 25, 50, and 100 respectively. But now let's do something interesting. Suppose that you wanted to combine the contents of two vaults, be it Harry's and Ron's or any other two people. How would you go about doing this in code? Well, if I wanted to combine the vaults for someone, I could do this. Well, I could do galleons equals, let's do potter.galleons plus Weasley.galleons. That gives me a variable called galleons that has the sum of Harry and Ron's galleons. Let's next do sickles equals potter.sickles plus Weasley.sickles. And then lastly, let's do knuts equals potter.knuts plus Weasley.knuts. I've got three variables. What can I now do with these values? Well, let's create a new vault. Total will be the name of this variable equals a new vault, capital V, notice. And now let's pass in those three new variables, galleons, sickles, three vaults, one for Harry, for Ron, and there we have it. Pretty straightforward, using techniques from weeks ago where we're just declaring a few new variables and doing some addition. But wouldn't it be cool if I could do something like and get rid of all of the later, we know as plus, vaults together. Through operator overloading, there is a way to do just this. If you consult the documentation, there's this and so many other special methods that come with classes. The third one we'll see here is this one here. Underscore, underscore, add, underscore, underscore. And you'll see that it very generically is described in the documentation as working for any object, be it a vault or a stir or a list or something else. By convention, it's going to take a first argument called self, and then it's going to take some other argument by convention called other. Self, in effect, is going to be referring to whatever object is on the left of a plus sign. Other is going to be referring to whatever's on the right-hand side of a plus sign, thereby giving us a way of describing in code the operand on the left and the operand on the right of the operator plus in between. That is to say, if I go back to VS Code here, what I'm trying to do is implement support for this. Well, let me try without writing any other code just yet. Python of vault.py, enter, type error. Unsupported operand types for vault and vault. That is to say, Python at this moment does not know what it means to add two vaults together, right? You and I might have an instinct, probably want to combine the galleons and the sickles and the knuts respectively. Python doesn't know that. It just knows that you have a new class called vault. But let's teach Python to do this. Let me clear my terminal window. Let me scroll back up to the class itself, where at the moment I only have two special methods, init and stir, and then a second parameter for this particular method called, by convention, other. Now, as always, I could name those parameters anything I want, but I'm going to stick with convention here. And now inside of this method, am I going to have to now add together the contents of two vaults? Well, what two vaults? Well, if we scroll down to our goal at hand, the goal, of course, is to add this vault plus this is it's going to call and is implementation of that as follows. Let me go ahead and define a local variable called galleons and set that equal to, for instance, the sum of self.galleons, whatever's in Potter's vault in this case, plus whatever's in Weasley's vault in this case, which would be other.galleons. Let me do the same for sickles, self.sickles plus other.sickles. And let me lastly do that for knuts. So self.knuts plus other.knuts. But at the end of the day, I'm going to need to return a brand new, bigger vault that contains all of those contents together. And if we ultimately want to assign that bigger vault to a variable like total here on the left, we'd better indeed return a value from this add method. So I'm going to go ahead and give myself a brand new vault as by returning capital vault, which of course is going to call my vault function into which I can now pass some of those initialization arguments. Well, how many galleons, sickles, and knuts do I want this brand new vault to contain? Well, I want it to contain this many galleons, this many sickles, and this many knuts. So ultimately, what we're doing in this implementation of add is adding together those galleons, sickles, and knuts, passing them to the vault function so that we get a brand new, bigger vault and return that all together. So now I've defined this new special method called add that should now just make plus work for 2 vaults. All right, let's see. Let me run down to my terminal window, python vault.py, and hit enter, and voila. Now we've implemented an overloaded operator plus to do what you and I as humans would hope would be the case when you add 2 vaults together, but I've now written the code more specifically to teach Python what it means concretely to add 2 vaults together. And it's with very similar code in effect underneath the hood that Python is doing this for 2 strings to concatenate them together. This example here.
How would you go about creating a function for adding a student and
figuring this out as I go here, Eric. So just to be clear, what I did was I just changed Weasley to stir just to see what would happen when I add a vault plus a stir. And it will work theoretically. Why? Because so long as the mean 11, because Python did not like this. Other.galleons didn't work, but I could make it work by figuring something out. Really good question. Didn't know that one myself. Other questions on, let me see what,
for 2,
or this example here.
How would you go about creating a function for adding a student and a vault for two separate classes? How would that be possible?
Let me see what happens here. I don't know offhand. Let's do this. Let's create a stir and see what happens if I add Potter plus a stir. Stir object. Yeah, okay, so it would work. I'm just figuring this out as I go here, Eric. So .galleons didn't work, but I could make it work by figuring something out. Really good question. Didn't know that one myself. Other questions on operator overloading?
Can you define new operators in Python?
I don't think so. There is a very long but precise list of operators that you can overload. I do not believe you can, my first instinct. No. Overload, you can do less than, plus equals, minus equals. Pretty much any symbol you've seen me type on the screen can be overloaded in the context of classes.